Alright, so now we're talking about factoring one more time since we're going to need this for rational rational functions eventually. So we're going to go over factoring, which we have done in the past. So for some of you this might be really easy, so easy that you may have to either fast forward or maybe even not watch the whole thing. Alright, but there's at least a couple, I would say, on the back that might give you a little trouble if you don't remember them. Alright, so anyway. Let's start talking about these. Now, remember, when factoring, you always look for your greatest common factor. That's always number one. All right, look for your greatest common factor. And if you have two terms, like you do here, notice there is no greatest common factor. So your only other choice is to find out if this is a difference of squares or a difference of cubes. But it couldn't be really a difference of cubes because this term is not even cubed itself. So remember, to know if this is a difference of squares, you have to have a minus in between those two terms, and you have to make sure that this 4, think of the square root of 4, and if you can think about it, and it is a whole number, this would be 2x plus 5, right? The square root of 25 is 5, and 2x minus 5. Now normally, that's pretty much it. Always look at those two factors that you have and see if you can factor one more time, and in this case you can't. Alright, so number 2, remember, always look for your greatest common factor. So number 2, my greatest common factor is 4x, and I end up with 4x plus 1. Remember that this inside of it came, once you find out what your greatest common factor is, divide each one of these by 4, and divide each one of these by x. So if I divide this by 4x, I get 4x. If I divide this by 4x, I get 1. Alright. On number 3, right, look for your greatest common factor. In this case, there's not. And then your very next step is to try to factor this quadratically. And by that I mean we need to have two parentheses. One with x, one with x. And this one, the only thing that makes a difference is that you have a y. You have a y term here. So really, all that it's going to do for you is you're going to end up with a y and a y here, but everything else works out the same. So all you have to do is think of factors of -6 that add up to -5. Now remember that if you have a negative, if your last term is negative, that must mean that one of these is positive, one of these is negative. Okay? Now on this one, so the two factors are going to subtract one another. So factor of 6, one positive, one negative, whose difference is 5 is going to be 6 and 1. You can put a 1 here or not put anything at all. Now remember, the signs are that if this is going to be a negative, my biggest factor is going to be negative and this one's positive. And if you're not sure, just add those two together. Negative 6y plus 1y is negative 5, well in this case xy, so you would have to basically FOIL this for that to make sense. So again, if you multiply this times this, you get 1xy minus 6xy, you get negative 5xy. Alright. On number 4, again, always look for your greatest common factor. In this case, we have a common factor of 7. So you have x squared plus 4x plus 3. And then now, I'm going to go ahead and just factor this. Alright, so remember, if the last term is positive, that means that you have the same sign. And not only that, because the middle term is positive, that means that both of these have to be positive, right? Factors of 3 that add up to positive 4, 3 and 1. Alright, moving on. Now on number 5, same idea, we're going to factor out an 8x. In this case, we have a common factor of 8x. So this is x squared minus 6x plus 9. Yep. And then I'm going to try to factor this like I did on the last problem. Alright, we're going to find factors of 9. Since this is positive, that means that we have the same sign, and this negative 6 means that they have to add up to a negative, so both of these have to be negative. So factors of 9 that add up to 6. 3 and 3. Alright, so that's how you do those, remember? Alright, if you have more trouble factoring, you need to come see us, because this factoring actually is going to get tougher as we go on. Okay. On number 6, we'll look for a common factor. There's not one. Alright, so if there's not one, you can do two things. You can either do bottoms up, or you can do the x factoring. If you remember, the x factoring is they're basically the same, right? Now I'm going to choose to do bottoms up. If you want to do the method that you learned earlier in the year, you can come ask Ms. Shelton or I to help you do that. Alright, so with bottoms up, you're going to multiply those two numbers, right? So you have x squared minus 7xy minus 60y squared. And then now, you're going to factor like this, right? Since you have a negative 60, that means the signs are different. So you have opposite signs, one negative, one positive. And then what you're going to do after that is that you're going to try to find factors of 60, one positive, one negative, so therefore they're going to subtract factors of 60 whose difference is 7. In this case that would be 12, well 12y because we have a y term here, and 5. Alright, so after you do that, on bottoms up, the thing that every kid always forgets is that after you find your factors, you need to divide each factor by the leading coefficient that you had here, right? So, and then you can either divide or reduce the fraction. In this case, I can divide evenly, so I will. Well, I'm going to rewrite this. I already rewrote it, but at the end of it, the reason we call this bottoms up is because we're going to bring the bottom of this fraction up, like that. Alright, so this is still going to be x minus 4y and 3x plus 5y. Again, notice that I didn't bring the y up beside the x, I just did that. Okay, now we're going to okay. So now we're going to go ahead and do number 7. Alright, so in this one, again, always look for your greatest common factor. In this case, you do have a common factor. Alright, let's see. Of 4. Alright, so we're going to factor that out. So that's going to give us 4. Let's see, this is going to be 6x cubed plus 2x squared plus 3x plus 1. Okay. Now this 4 is going to stay out here. It's not really going to affect anything else you're going to do from now on, right? It's just going to be out there. So I'll show you how to do the rest of this. So now, if you want to ignore the 4, that's fine. But what you're going to do here is you're going to find factors. When you have 4 terms, you're going to find the common factor between those two now, which in this case is 2x squared. And if I do, I'm going to end up with 3x plus 1. And then you're going to try to find the common factors of those two. Now in this case, it doesn't have a common factor other than 1, so at least factor that out. So we're going to factor a 1 out. Now the important thing about this when you're doing factoring by grouping is that you have to have exactly the same thing here and here. Okay? And if you do, then you're doing this correctly, or this can be done with factor by grouping. Alright, so now what we're going to do here is we're going to bring those two numbers together. Alright, so we have 2x squared plus 1, and this is 3x plus 1. Alright, so notice that these two became 1. And for reasons that I've explained earlier, so if you have more questions about that, you can ask me in class. And then this form is going to rewrite it right there, and that's it. Okay. Now on number 8, same thing. Is this factor by grouping? We're going to go ahead and try to look for a common factor. In this case, there's not one, so we're going to go straight into factor by grouping. So look for the common factor between those two, which is 6x squared, and that's going to give me 5x plus 3. Now normally, if this term is negative, you're going to factor out a negative, or a negative 1 to be precise, and that's going to give me a 5x plus 3. Now again, please notice that I have the same thing in this 2 parentheses. So my answer is going to be this. Right, remember that I grab those two and I put them together, and I just write one of these. Always check to see if this is factorable. This could have been factorable except for this 6 is not a perfect square, so you can't really factor one more time. It turns out that you could if you really wanted to, if you want to make this plus or minus the square root of 6, but that gets kind of not complicated, but just kind of picky about what I want. I don't want you to be confused about what I want. If you get this, and these are not perfect squares, well, then you can't factor anymore. Alright, let's go over 9. Alright, same idea, look for the common factor. In this case, there's not one. Alright, so we're going to go 4 terms, so we have factor by grouping. Factor out an x squared, so we're looking for the common factor between those two. And I end up with 2x plus 1. And on this one, we have a common factor of 9, but remember, this is negative. I'm going to factor out a negative 9. So it's going to give us a 2x plus 1 also. Okay. Now remember, we're going to bring those two numbers together, so we have x squared minus 9. And this is 2x plus 1. Okay? Now that I have those two, right, check each term, each factor that I just got, and see if you can factor one more time. 2x plus 1 definitely can't, but x squared minus 9 you can. This is a difference of squares. Remember, this is a square number, and this 1x squared is square number 2, technically. Alright, so to factor that would be x plus 3x minus 3. And this would be 2x plus 1. Alright, so that's it for that.